Susan's grandmother gave her $34 for her birthday. Instead of spending the money, she decided to save the $34 and then save an extra $250. $250? What am I saying? $2.50 every week. Okay? So write a recursive routine. We're not quite ready for recursive routines, but we're going to write what we know, and we're going to start with this. A sub 1 is 34. The first term that we know is $34. Okay? And then we know she is going to add, or what am I doing? Added $2.50 every week. Everybody know what this means? $2, because I wrote a slash. Do I want her to slash $2.50 every week? What does that slash mean? Per. You okay with that? $2.50 per week. Okay? So we're filling in the table right here. So we say, we know she starts with $34. What week is that? How do you know it's 0? Because that's when time is starting. Okay? So at 1 week, how much does she have? $36.50, because we added $2.50. What about week 2? $39. What about week 3? $41.50. Go ahead and finish filling in the table. After you finish filling in your table, look up at mine and check to make sure it's the same. Okay, do you have your table done? Now we have to make the graph. The graph that's on this piece of paper right now is missing 4 very important things. Can you tell me what those 4 things are? What you got? X and Y axis. I need an axis first of all. Where are my axes going to go? Do I just automatically put them in the middle every time, here and here? That's where they usually are, isn't it? Where do I need it for this problem? Sir? So far on our table, all of our values are positive, he's saying, right? So is there any chance they'll be negative? We're going to go backwards in weeks? No. This amount of money is increasing, so is it going to go negative? No. So I can put my y-axis right here, and my x-axis right here. Okay, good. So that's one of the 4 things. What else? We have to number it. We have to scale it somehow, right? So how do you think I'm going to scale my x-axis? How do you know it's by ones? So how do you know that weeks is right here? It's in the first column. What would be better for me to do right here then? It's something else that's missing, just so you know. Yeah, the labels. This is really time, right? Time in weeks. So can we do 2 things at one time? Can we scale the y-axis and make sure it has a correct label? Okay, so how should we scale it? Where does it have to go to? At least 5150, right? 5, 10, 15, 20, 25, 30, 35, 40. This 5's going to work? 10, 20, 30, 40, 50, 60, 70, 80. Will 10s work? Okay. What about 7s? Okay, wait. Do you really want to use 7s? Yeah, I don't either. Okay? It's something I want you to think about, though. Okay? 5s and 10s are easier, aren't they? 20s, 100s, whole numbers, rounded numbers, nice numbers like that are always good. But it's a thought. Just kind of keep that in the back of your head. So 10, 20, 30, 40, 50, 60, 70, and 80. And what is that? Money. So now what? I'm still missing something. A what? We can plot our points in a second, but before we even plot our points, I'm still missing one more thing. Yep, a title. What should we call this? Savings plan? What might be a slightly better title than just savings plan? Susan's savings plan. Okay? Now what do we have to do? Now we can plot our points, right? So 0, 34. Oh, wait. Can I get exactly 34? Not in a graph this size, right? But I need to get close. So it's not quite halfway, a little bit less than halfway. 1, 36.50. 2 is 39. 3 is 41.50. 4 is 44. 5 is 46.50. 6 is 49. And 7 is 51.50. Whoop. Is yours close-ish to mine? What operation did you repeat when we made this table or in the routine? So we repeated addition. What does repeated addition look like on a graph? You're showing me with your hand the right way. Can you find the right word? I didn't hear you. I apologize. So increasing line. What's another way to say this? Say it again. Yep. Positive what? Positive slope. Not slop. Slope. One more way to say it differently. Kind of differently. A positive what? Yes. Positive rate of change. Relatively speaking, at this point, don't all those mean kind of the same thing? Yeah, we need to make sure our vocabulary is good. Okay? For the record, those are not all exactly the same, but we'll talk about that as the weeks come. Okay? How much money will Susan have after 12 weeks? How would we figure it out? For the record, I know about 18 ways to do this problem. Maybe 17. That might be pushing it. What? So making an equation is one way. What kind of equation would you make? 12 times 250 plus what? 34. Will that give me the right answer? You know what somebody said earlier? Take the 6 and double it. 6 weeks to 12 weeks, shouldn't that double? Why not? Because why? Wait, so what if we took away one of the 34s? Would that work? What is 12 times 250 plus 34? Anybody? 250s is $5, right? So 6 of the $5 would be how much? 30 plus 34? 64? So what if this ridiculous person who suggested this earlier, what if we just doubled this? What's 49 doubled? Seriously, what's 50 doubled? 100 minus 2? 98, right? What's 98 minus that extra 34? Oh my gosh, 64. They weren't that ridiculous after all, were they? Okay. For the record, though, if all you wrote in this blank is 64, that's not the right answer. 64 children, 64 boogers, 64 bags of chocolate, those are all completely different things. You have to have a label so I know what you're talking about. What are we talking about here? $64. When will Susan have $51.50? 7 weeks. And how do you know that? Yeah, we read the table. Okay? If she needs $100, how long must she save? I want you to work on this for a second. Some of you already have the answer, and I appreciate that. But I want you to work on this for a second. If Susan needs $100, how long must she save? How are you guys doing this problem? How many of you just started the list like 8, 9, 10, 11, 12, 13, and you're just adding 250 every time? Is that an acceptable way to do it? Yes. Is that an efficient way to do it? No. Who's doing it a different way? What'd you do? So you did 34 plus 2.5x equals 100. So you're solving an equation then. Good, that'll work. Because we subtract 34 from both sides and get 2.5x equals 66. And then divide both sides by 2.5. And then because I'm an evil math teacher and haven't given you your calculators yet, you're having to do long division, right? 2.5 divided into 66. We got to move our decimal over. Yeah, don't tell people I tell you that, because that's not the right vocabulary. I'm sorry for that. Okay? We're not just moving, like it's not magic. We're not just moving the decimal over. You know what's going on, right? Okay? 25 goes into 66 twice, and that's 50. Oh, and it's this decimal too. So I have to add a 0, add a 10, right? So that's 16 left over and a 0. So that's 6. So that's 150. So I have 10 left over. Add myself a decimal. So I have another 0, and that's 4. Right? So did you get the answer of 26.4? Is that what goes here? Why is it 27? If you do 26, it's less than 100. And is she getting a little bit, is she saving a little bit of money every day? Or is once a week she's saving 250? Once a week she's saving 250. So in order to get to the 100, I have to wait one more week. After the 26th week to the 27th week. Now, won't that put me over $100? Yes, but she needs 100, so she can't have less than 100, can she? She can have a little more than 100, that's fine. Okay? Who did it differently? You all set up an equation and solved it? Okay. Some people did this same kind of thing, but it wasn't from an equation. Okay? They just said 100 minus 34, because like we did a minute ago, we subtracted what we started with, the 34, and we knew whatever was left had to be some multiple of 250, because that's how much she's saving each week. Okay? Anybody do it differently? No? Okay. I'm okay with that. After 21 weeks, how much will Susan have? How much? $86. How did you do that? $21 times 250 plus 34. How do you do this, guys? Did you set up the algorithm 21 over 2.5 and then multiply, multiply, multiply? Have you guys ever heard of something called numeracy? Numeracy is how comfortable you are with numbers. Okay? First of all, because of genius. I'm a genius. And second of all, because I'm feeling more comfortable with numbers, I can do this problem without a calculator and without really writing anything down. Can I show you how? Okay, let's see. I'm going to pretend this is 20 for just a second. I'll come back to 21, but let's pretend this is 20. Even 20 times 2.5 isn't that easy, is it? But I know 20 is really the same as 10 times 2. Can I say that? 20 is 10 times 2. Well, 2 times 250 is easy, especially when I'm thinking about money, because that's $5, isn't it? Well, what's 5 times the 10 that I had left over here? 50. And then I have one more. Remember I ignored it for just a second? What's 50 plus 2.5? 5250? What's 5250 plus 34? 8650. And that is the correct answer. Is that the only way to do it? You know what that same crazy kid earlier said? Why can't we multiply this by 3? Because if we're trying to get to 7 weeks, to 21 weeks, can't I use that 7? And I said, well, it depends. And he said, well, look, if you say 5150 times 3, you'd get 154.50. Is that the right answer? No. But he also remembered that what? An extra $34? Wait, an extra $34? 2 extra $34, right? Because we can have 1, we just can't have 3. So if he subtracted 34 here and got 120.50 and then subtracted 34 more, oh my gosh, 86.50. Ma'am. You had to subtract 34 twice because we multiplied it by 3. So I got to take away this 34 and this 34, so I only have 134 in there. Good question. Okay. Couple things I'm trying to get across here, guys. How many different ways was there to do this problem right here? At least 3. Plus, some of you guys may have done it a little bit different and gotten this answer, right? Are you getting my point? Not always just one way to do a problem. Fair enough? Okay, look at the back. Manuel worked all summer and saved $1,092. He plans to spend $35 a week. What do we know? What can we write down? What can we write down? Like we did on the first problem. A sub 1? 1,092. And then what? Subtract $35. What do you think he's doing, like paying for Wi-Fi or something? $35 a week? It's not gas. That's way too low for gas. Right? Can you rent PlayStations for $35 a week? I know. Do what? Oh yeah, you could do that. Absolutely. $35 a week. Thank you. So let's start filling in the table. What goes here first? 0, 1092, right? When it's week 1, 1057. How'd you get 1057? Subtracted 35, right? What about week 2? 1022, because we subtracted 35. So week 3 is 987. Week 4 is 952. Week 5 is 917. Week 6 is 882. Week 7 is 847. I need a title on my graph. You see why I made you change your title a minute ago when you just said it was spending plan? I made you change it to Susan's, or strongly recommended that you change it to Susan's, right? Because now we have 2. Now we can tell the difference. Okay? So we know we have time here, and we can probably count, not probably, but we can count by ones. And we have money here. Ooh, how are we going to count here? We got to get up to a little over 1,000. 100, 2, 3, 4, 5, 6, 7, 8. Say again? I just didn't hear you. Okay. If we start at 100 here, that still gives me 100, 200, 300, 400, 500, 600, 700, 800. Like we could put a squiggly line here if we wanted and start like that. What's another thing we could do? We could count by 200s. 2, 4, 6, 8, 10. So that's still right there. What about 150? 150, 300, 450, 600, 750, 900, 1050? Would that work? Probably a better use of our space, right? And it's not a number like 7, like we talked about before, right? So 150, 300, 450, 600, 750, 900, 10, 50, 1,200. We good? So we got to plot the points. And we got to do it kind of fast because we're running out of time. What operation did you repeat? Subtraction? How does this represent subtraction? How does this repeated subtraction look on the graph? It looks like it's decreasing, like a decreasing line, or negative slope, right? Okay. How much money will Manuel have after 8 weeks? $812? Where in the world did that come from? We know 7 weeks, so can't we just subtract $35 more? Okay. When will Manuel have $637? How are we going to do this one? I'm just writing down what you're saying. That's okay. 637 equals. You want to solve equations like that all the time? You can. It'll get you the right answer. Okay, that's one way to do it. "13 weeks. If Manuel needs $100, when must he stop spending?
Miss Kingston,
Yes, ma'am.
do you have Tara Laura? Tori Laura.
No, ma'am, I don't believe so.
Okay, thank you.
Yes, ma'am. Terry, you need to go pick up your lunch before you go to lunch, okay? Don't forget. If Manuel needs $100, excuse me, when must he stop spending? He started with $10.92, right? If he needs $100, how much is he allowed to spend? $9.92? What happens if I divide that by 35? What do I get? 27 something? 28 something? So it's got to be 28, right? 28 weeks? After 19 weeks, how much will he have? Good. Look at Susan and Manuel's money plans. Which one looks like walking away from the CBR and towards the CBR? So Susan's is walking away because it is increasing. Manuel's is walking toward because it's decreasing. Any questions? If you have some, please come see me in tutorials. Have a wonderful day.